I will talk about quality and testing, and especially focused on the brain simulation platform. And as we heard on the talk before, some kind of testing is very important for to provide quality for your software, product, use case, whatever. So what is quality? So there are some different definitions of that, which you can read here, but essentially it's about the same thing. It's about the degree of how a system fulfills some requirements. So some end user requirements, something like that, if you have some requirements at all. So why is quality important? So quality has an effect on many, many different things. And when there is a bad quality or you have a software bug in a system, it can have devastating results. Like when they tried to launch Ariane 5 in 1996, the first attempt did not work, and they had it was a loss of about 500 million euros. So what happens here, so this is a typical software bug. You have a system which was trying to estimate where the rocket was going, and you have some other system to steer the direction of the rocket. And from the one system you had a 64-bit floating point number, and the system was converting that into a 16-bit signed integer. And 30 seconds after launch, this number got bigger than 65,535, which is the maximum for a 16-bit integer variable. The conversion did not work, but instead that integer variable contained some debug value, which the other part of the rocket was actually using as a correct input value. And from there on, things got not really nice. Another example of a failure because of bad quality is the loss of the Mars climate orbiter in 1999. So here there was also two systems, and the one system was providing data in the US imperial units, like force pound something, while the other unit was expecting the result in Newton. And so there was an offset of a factor of 4, which led to the crash of that 300 million experiment on Mars. So here, conversion of units is important. And I mean, when there is one tool which expects some voltage in volt and the other one in millivolt, yeah, you can easily have a system which might not really work. But when you do brain simulations or other neuroscientific work, it's unlikely that the brain will explode or crash on Mars. But there are other quality aspects which are important, which can lead to other damage, like reputation damage. So that has been seen in the case of the Wells Fargo scandal in 2016, where some user accounts were publicly available or something like that, and they were fined a couple of $100 million. But overall, the total damage in reputation, it was about $3 billion. So you might think about not only to have your software and tool work, but also what you should think about is that other people outside of HBP, for example, might see your tools or your Jupyter notebooks and so on. And I think some kind of reputation should be put to a high level. So what So there are several quality characteristics you can have for some system. The one is what you probably know about functionality. You have a system and you want it to work. So, but that's only one characteristic. Another one, for example, is performance. When you have a tool or software, you don't want, you know, when an end user is trying a Jupyter notebook and he has to run it for 1 hour, well, it might not be the best use case, so it should be running in a couple of minutes or something like that. So that's something to think about. You have also security, like access of data or something like that. You want maybe have your data private. Then you have other characteristics like availability. Is the system running? Do the service running? Can I use it right now? And one important aspect is usability of a system or a use case. So it's the kind of ease of use, a clear layout, a look and feel, and learnability of using some tool. So you want different tools kind of having the same look and feel, so you don't have to learn a different usage all the time. So an example of a bad usability web page is this. So it seems to be kind of a trading web page like eBay, but it's completely out of the place. There is no layout, there is no look and feel, it's all colors, so it's not really usable. A good example of usability is this one. You might have seen that before. There's only one text input box, and that's about it. A user cannot really do anything wrong with that. It's just simple. But then there are some other characteristics which are non-runtime qualities. One of them, for example, reusability. So they not to reinvent the wheel, which sometimes I have the feeling happens in the Human Brain Project, that several teams are trying to do the same thing again. And maintainability. So that is, in fact, the usage of the code quality itself. Is it good written? Is it easy to understand? I mean, code can be written in, it can be spaghetti code, like 15 pages long. It might work, it might be performant, it might be usable, but when an outside user sees that kind of bad code, it's not a good reputation for Human Brain Project. And so one example, what I kind of have seen in the text is like that here. You have some code here which defines some widgets. So that's actually an example that actually works. But what you can see at once, first you have to scroll to the right to see it all. So you cannot see it at once. And then every line has some formatting structures here, and you cannot really compare them. Are they the same? Are they different? It's not really clear what's going on. It can be made better like that. So you define your kind of template. You have your styles in one place. You can easily see, okay, that's your style. You can easily change that, and then you define the widgets here with only the title you want to change. But even when you go a step further and you know a bit of Python, you can even have it more compact, like that, where you have some list comprehension. And if you even know better of PyWidgets, you don't have to have this HTML template at all. But I didn't figure out how this works. So what I recommend for that is really to try out and check for kind of Python code tips and tricks, which I did. I put them in this guide collab here, and I think I know quite some tip and tricks, but when I look at the results I get, there's always something that I did not know before. And it's really helpful. And of course, use Python 3. Python 2 will be deprecated in about a month. So if you develop something, I always suggest to use Python 3. And then in this collab here, I have put together some draft version of a kind of Jupyter Notebook guidelines, which have some suggestions of maybe how to create a Jupyter Notebook, especially for the brain simulation platform, to have a common code standard, a common look and feel. And so this is collab 69119. So if you don't remember, if you can't remember this number here, it's pretty easy. Just look up the coast code for this place where we are. It's Heidelberg 69120, and you subtract 1. So what I recommend is something like that. When you have a notebook, start it with some structured introduction, aim, aversion, contributors, maybe credits, thanks. Then you can have also literature. You can create colored boxes in your notebook. You can do that as well in the new notebook as well. Setting up the environment, you can use red boxes for some warning. And then I would go like that. First you install whatever you need, then you import what you need, and then you initialize what you need. I think, or something like that. So it's kind of a structured thing, and then you can use other colored boxes to kind of explain more detailed like equations or details of your use case. And do some bit of coloring in the notebooks. So I think to have some color to present something, it looks very nice. So, but why do we need now testing? And also what I'm doing. So when the developer tests, everything is always okay. No problems. When the quality team tests, yeah, okay, there might be a warning. You should look after something, fix that. So, but if there's a quality team and the product manager tests or project manager, yeah, you might crash something. And the worst you can do, you have no testing at all. The end user tests, boom. And also, what you should think about is that the cost of fixing a problem, it might not be a bug or something like that, but something that is not good quality. In the beginning it costs less. I mean, cost in a term of time investing or resources to use for that. And when you are at the end, the uses of resources are much higher. So the thing is to start with quality as early as possible. And but now I'm here at the end of that thing. I'm in the testing area, so now I test. So why do I test? Why do we need this testing? So for example, imagine you have an input box where you can input some value, and the developer puts in the value who is fine. It works. But now I try to break the system. So what happens if I don't put in anything at all? Or 0. Or I can put in a negative number which is not expected. Or a very large number. Or I put in some text. Or some special characters, Unicode, whatever. What happens? That's what I do. And then, of course, so for testing the brain simulation platform itself, for the use cases and also live papers, MOOCs, and so on what there is. Of course, I do these positive tests to make sure that it works. But also I do some negative tests, try to provoke an error, like put in some text when the text is expected. Also see if the error makes sense, info to the user. I also verify layout usability and check the documentation, which always comes last. And then I try to do also some user testing. So I ask other scientists who might use that tool to take a look. And the feedback from them I get is very useful in terms of understandability, usability, and things like that. I also do automated testing. So these are testing the graphical user interface, also using Jenkins Docker, Selenium for Firefox and Google Chrome. And I do some API testing as well. And just to show how this automated Selenium testing works, so I have repositories, I have a Docker image, I download that Docker image into a Jenkins job. In the Jenkins job, I run the Selenium tests, and in the end, I get some notification on Slack, which tells me our test did work or did not work. An example of what the code looks like is that. So here I test a notebook. So here I get some driver of the brain simulation platform where I already logged in. I define the name, use cases, and then I call a function to which creates a new collab, runs the test, and so on. So whenever there's a new notebook, I can copy and paste that small piece of code, just change the name, and that's about it. And I have prepared a live demonstration. So this is running on the laptop. So I'm using PyTest, and let's see what's happening. Of course, the browser gets on this screen. So it opens a browser, it logs in with a test account. So here it selects a use case. Trace analysis use case. So that's also one of the use case that was part of Luca's use case. What he showed this morning is a new collab is being created. And then the script selects some traces. Goes to the next page, and here I select some features. And then the instruction is being done, sent to some backend. And then I can download the result. Actually, the test script is downloading the result and compares the result with values I have from previous runs, and at the end, a test passed.
Just curious, does the test script pick the same features every time, or
it's in that case, it's the same features every time. Yeah. I could change the features randomly, but then I were not able to kind of check the result, and I'm not sure if it makes sense, because when this runs, then I can see backend, etc. is working, so it looks good. Yeah, and these tests are also divided into different sets, so they can run in parallel. And when everything works, I get all with a green check mark. And if it not works, then I have debugging possibilities. I have this console output where I can get some information. I have screenshots. I was able even to create a full page screenshot of a Jupyter notebook, so the whole long notebook in one image, which is helpful. And I do also a video recording of the virtual screen in the Jenkins test. Then I do also some API tests, so that's a direct access to services and servers backends, so no GUI involved, so less complex. Interesting is that the pointability, because when a use case uses several services and backends and it fails, it's always kind of hard to say why it did fail. But when I use these API tests, which are talking to one service, I can immediately say that this service has failed. And of course, it's faster, no login, no browser, startup, and so on. So the takeaway for you, some quality control is in place for the brain simulation platform, but of course it's not 100%. I miss something, of course, and that's why I need kind of your help when you develop something, because quality starts early in the process. So your help is really required in the design and development phase with quality in mind to look out for the usability of the use case, maintainability, and also to think about a look and feel so that for the end user it's a good experience and they want to use the use case again. And that's it for me. Any questions or comments?